Alright, my name is Alexis Mann and I will be doing my presentation over reciprocal innervation. Reciprocal innervation was discovered by Sir Charles Sherrington. He came up with the term and characterized it as responses in the nervous system, such as excitatory and inhibitory behaviors that are closely related. Sherrington also coined the term synapse, which is a hypothesized space for neurons. In addition, this led to his interest in reflex action in what he called spinal dogs. Spinal dogs were those who had their spinal cords severed from their brains. He knew that regular dogs had the reflex of shaking their leg whenever their side was rubbed, so he tested it out on the spinal dogs. And interestingly enough, he discovered that the spinal dogs had greater reflex memory than the regular dogs, which backed evidence that the cortex has an inhibitory effect on reflex action, and also that the spinal cord plays a role in reflex action. Reciprocal inhibition is moderated by a dysynaptic circuit, meaning reflex hinders muscles opposite of those in movement. Sherrington was aware that most of this wasn't new information. However, he now had evidence that actually explained how coordinated actions were carried out, like in walking or balance. Reciprocal innervation usually utilized antagonistic pairs, and reciprocal inhibition used agonist groups that relax, so antagonist groups may contract. Past research suggests pedaling can be a beneficial tool in locomotion in regards to spinal cord reflexes. For example, a study from Yamaguchi and others in 2012, they utilized active pedaling paired with an electrical stimulation, which helps aid in spinal cord reflexes. In contrast, a study by Molt, Cottrell, and Lee, 2013, explained how there is a lack of support for locomotor rhythm generation. In this study, they utilized tadpoles to better explain reciprocal inhibition. And in this study, they found that the hindbrain and spinal cord of the tadpoles actually depended on each other for them to maintain their swimming rhythm. And whenever recording the research, they also revealed rhythmic inhibition from the intact side and not the suppressed side. Therefore, the presence of silenced neurons on one side led to the rapid progression of movement on the other side. And then there is my references.